Today we're going to talk about inequalities and set notation or set builder notation and interval notation. So far we've been looking at situations where we have numbers, say a number times a variable, and we'll set that equal to another number. And it's very concrete. You know, the steps that we take in order to solve this would be to use either the addition or the multiplication principle, in this case multiplication principle, and discover that 80 divided by 5, when we divide both sides by 5, we're left with just the x over here, and 80 divided by 5 is 1/16. And that means that on a number line, if we were to create a graphical representation of the solution set to this equation, let's say we had 14 here, 15 here, 16 here, and 17 here. This would mean that the solution to this equation is only this value right there. That's what inequality is. Now let's take a look. Instead of having this symbol right here, instead of it saying 5x is equal, what does it change if we were to say 5x is now not equal to, but instead less than 80? Now the only really thing that changes is our solution set. The process is going to be exactly the same, whether we have 5x equal to or 5x less than 80. And the process is still to divide both sides by 5 and to say that x is now less than 16. So the way it works is, let's take a look at another number line, and instead of saying 15, 16, 17, instead of saying that this exact spot here is x, we can now say any replacement value for x occurs below this 16 here, whether it's a whole number, an integer, a rational number, or an irrational number. It'll be all values on this number line below 16. So we'll have to shade everything from the left of this parentheses all the way to infinity, basically, of 16 here. So x is less than 16. This open parentheses, this one here, means less than. The numbers are going to go in that direction. They're going to go this way, less than. To have, say, an open parentheses in this direction means greater than, which means, again, the numbers are going to point that way. The numbers are going to get increasingly bigger. All of those solutions would be okay. Other inequality solutions would say greater than or equal to, less than or equal to, and the way to write these on the number line would be to use a square bracket. Now since this one says greater than, it would be a square bracket opening to the right, and then all the numbers would point this way. This one says less than or equal to, which means it's a square bracket opening to the left, and then all our numbers would point that way. Now the set builder notation would tell us to take this answer for x, the solution set for x, and to put it in squiggly brackets, and we'll say, and this is how you read it, you say the set of x, in the squiggly bracket, the set of x such that x is less than 16. And mathematicians, if nothing else, try to be a little more efficient with how they denote things. So they invented something called interval notation. And interval notation looks familiar. It looks a lot like something else, but it is definitely not the same thing as doing coordinates. And I'll show you what that means. This solution set again. So this is set builder notation with the x is less than 16 set. What this solution says in interval notation would be the smallest number in the interval, which, since we go below all the way down to negative infinity, right, it can be all numbers that are below 16. So it's an interval from the smallest number in the solution set to the largest number in the solution set. And because it doesn't include that largest number, see how we use the parenthesis symbol here, then we have to use the parenthesis symbol there. So again, this is where this terminology comes into play. These symbols means that they do not include, these do not include either the minimum or the maximum number, whereas these symbols here say that they do include either the minimum or the maximum number. Let's take a look at one more example. So let's take a look at another example. It says, let's say negative 3 times x plus 4 is less than or equal to 31. So this time one of the differences we have is that now we have a less than or equal to, and we have a little bit more complex of a statement here. Here we're taking x, multiplying it by negative 3, and then adding 4 to get less than or equal to 31. So remember, to unpackage that, we have to do the exact opposite. So the first part of that opposite would be to subtract 4 from both sides. These will then cancel, and I will be left with negative 3x is less than or equal to 31 minus 4 is 27. So now we have an inequality that says negative 3 times a number is less than or equal to 27. So the opposite function here would be to divide by a negative 3. Now since it is true that negative 3 is less than 0, one thing that we have to do is take our inequality sign and reverse it. We change it now. So now it doesn't say negative number is less than. We will say a positive number, because a negative divided by a negative gives you a positive. So now a positive number is greater than or equal to a negative 9. Now how would we write this in set builder notation? Set builder would say the set of x such that x is greater than or equal to negative 9. That's it. Now interval would say, since it does include negative 9, we have to use a square bracket around negative 9, and negative 9 is the bottom of our interval. It's the minimum number. So we use a square bracket around negative 9 because it includes negative 9, and we're going to go all the way now to a positive infinity, and anytime we reference infinity we will use a rounded parentheses. So remember, interval notation is a minimum and a maximum number. We use round to indicate it doesn't include, or square to indicate that it does include.